Assalamu alaikum warahmatullahi wabarakatuh. Today I'm going to talk on basics of artificial neural network. Before going through that, I'd like to introduce myself. I'm Sabi Ahmed Khan, currently pursuing my master's from Chang'an University, Taiwan in computer science and information engineering. And my research interest includes machine learning and big data analytics. You can find my blogs over here and you can connect with me on LinkedIn via this URL. Today's talk contains this outline, introduction, perceptron, multilayer perceptron, and at last I'll provide the references. Before moving ahead with artificial neural network, first I'd like to introduce to the biological neural network, because artificial neural network is just an analogous to biological neural network. As you might be aware that our brain contains around 10 to the power 11 neurons, and each neuron communicates with another neuron uh, through electrochemical signals which transmit from one neuron to another neuron. And similar case we are using in the artificial neural network, in which signal gets transmitted from one neuron to another neuron, where some processing happens in each neuron to provide the required outputs. So let's take an example here of like a patient visits a doctor because he's suffering from a fever or some any disease or whatever. In that case, a doctor needs to identify the problems. For that, he needs to read the reports, listen to the symptoms of the patients, and then provide the proper medication. And suppose we need to we want to accomplish the same task via machine, so how we can do that? For that, in the case of machine, first it needs to identify the object, that comes under the visual object recognition. Next is the speech recognition, that is hearing. And the third one is the text understanding, that is understanding the reports that the machine is having. So all these tasks comes under the perception tasks. So here we have the similarities here. In case of humans, we are using the biological neurons or biological neural networks to accomplish all these perception tasks, and in the case of machines, we are using the artificial neurons to accomplish this task. So what is biological neural networks? Here we have like multiple neurons in our brain, and here we have a dendrites, and here we have axon terminals, and the signal is received by the dendrites, and after receiving it, it transmits these electrochemical signals from one neuron to another neuron via axon terminals. And in the enlarged view, you can see here that electrochemical signals transmits from one neuron to another neuron as a neurotransmitter molecules, and it passed through a synapse, and there is a gap between two neurons, and this acts as a link in between two neurons. So similar concept we will use in the artificial neural network. So here in the case of biological neuron, we have dendrites, and it passed through the nucleus, and then it provides the output at the axon terminals. Similarly, in the artificial neuron, we have multiple inputs. It passed through the neurons, some processing happens here, and it provides the output. So let's look into the perceptron, which is having a neuron, and multiple inputs are provided here, and which pass through the synaptic weights. As we have a synapse in biological neuron, we have a synaptic weight here in the artificial neuron. And each weights identifies the strength of each connection to the neuron. And here we have a summation of this product of input and weight. And after this, in the neuron, it passed through the activation function to normalize the result. And for the activation function, we can use a threshold function, which provides the output as 1 if this a product of sum gives the output as greater than 0, and if it's less than or equal to 0, then the output of the threshold function will be 0. And the other functions that we can use is a sigmoid function as well as a hyperbolic tangent function. So let's train this perceptron for an OR logic gate, in which case the output should be 0 if both the inputs are 0, and in all the other cases the output will be 1. And here we are using a bias as +1. So let's see how the training works here for the perceptron. So after passing through the weight of -0.5, it gives me the output as minus zero point 0.5. And here these weights are randomly generated, that is minus 0.50 and zero point 0.5. Depending on the output, we'll need to modify the weights accordingly if it gives me the wrong output. So let's see, the first input as a 0 and it provides me the output as 0. So the second input as 0, it provides me the output as 0. Now here the combination is minus zero point 0.5, and after passing through the threshold function it will provide me the output as 0 since it is less than 0. So the output is correct here. So for next training is 0 1. Let's try here. That is the first bias provides me the output as minus zero point 0.5. First input 0, second input 0.5. So overall it gives me the output as 0. So here after passing through the threshold function, it provides me the output as 0, which is wrong. So the weight modification needed here. So here I'm changing minus zero point 0.5 to minus zero point 0.2 and 0 to plus zero point 0.5, and let's see the output. So the first one with the bias provides me output as minus zero point 0.2. First input provides me the output as 0.5, second input provides me the output as 0. So overall summation comes at 0.3. So after passing through the threshold function, it gives me the output as 1. So this is the correct. But still there is a possibility of weight optimization, because here we are getting f.3 as is equal to 1. So we can also get f.1 is equal to 1. So let's optimize the weight again, and so we are changing it to minus 0.1, 0.2 and 0.2. So for the bias, it provides me the output as minus 0.1. For the first input, it provides me the output as 0.2. Second input also 0.2. So overall it gives me the output as 0.3, and after passing through the threshold function it gives me the output as 1. So this is correct. So after the optimization, let's check if this weight optimization gives me the output correct for the 0 1. So for that, the bias gives me the output as minus 0.1, first input 0, second input 0.2, that is 0.1. So yes, so after passing through the threshold function it gives me the output as 1. So here the weight is optimized. Now let's move ahead to the multilayer perceptron. Here we have a single neuron, so we are able to train the OR logic gate. But for the XOR logic gate, we can't accomplish this task via single neuron, because for the OR logic gate, this is a linearly separable, as you can see, like first output is 0 and the rest of the other outputs are 1. But in case of a XOR logic gate, we'll be having if the inputs are same, then it provides the output as 0, and if the inputs are not same, then it provides the output as 1. So that those are non-linearly separable. So for that we'll need a multilayer perceptron. So let's move ahead for the multilayer perceptron, in which first here we will get the weighted sum of the hidden layer, which provides the output with this equation, and after that it passed through the activation function. If you any function, we can use a sigmoid, threshold, or whatever we need as per the requirement. So here we are using a sigmoid, then in that case we can get the output. After this, this output of this hidden layer will act as an input in the output layer. So it gives me the output. After passing through the activation function, it will give me the proper output for the multilayer perceptron. So let's move ahead with the training of the XOR logic gate. So for first, my bias passed through the 0.2 and it gives me the output as 0.2. First input gives the 0.6 multiplied 0 0, and the second input also 0. So overall it's give me the output as 0.2. Passing through the threshold function, it gives me the output as 1. Similarly for the second neuron in the hidden layer, we'll need to move ahead, and it gives me the output as 0.3. So after passing through the threshold function, it gives me the output as 1. So now these these two output of the first hidden layer will act as an input for the output layer. So after this, the output layer weighted sum come out to be 0, and the threshold function gives the output as 0. So this is correct. Next, let's move ahead for the 0 1. So the first neuron gives me the output as 1, and the second neuron gives me the output as 0.7, and again after threshold function it gives me the output as 1. For the output layer, it gives me the output as minus 0.5, 0 and 0.5, that is 0. So the output is 0, which is not correct. So here we'll need to modify the weights. So for the output layer, we have modified the weight from minus 0.5 to minus 0.1, and the last weight from 0.5 to 0.2. So let's move ahead again, and the first neuron gives me the output as 0.8, which after passing through the threshold function gives me the output as 1. And for the second neuron in the hidden layer, it gives me the output as 0.3, 0.7 and 0, that is 1. So after passing through the threshold function, it gives me the output as 1. So this will act as an input for the output layer, and this after summation gives me the output as 0.1. So the output is 1. So this is correct here. Next, for the 1 1, let's check. And here the first one gives me the output as 1. For the second neuron, it gives me the output as 1.4. So that is threshold function gives me the output as 1. So this acts as an input for the output layer, and we get the total summation as 0.1. So it gives me the output as 1, which is not correct as per the XOR logic gate, because the output should be 0 here. So we need a weight modification again here. So here we changed from first hidden layer weight from 0.7 to minus 0.7. Let's see the output now. In the first neuron, it gives me the output as 1.6, that is 1 for after passing through the threshold function. Next, in the second neuron, first bias provides me a minus 0.3, then minus 0.7 for the first input, second input gives me a 0.4, so it's 0. After passing through the threshold function, it's give me a 0, and now this will act as an input for the output layer. First gives me the minus 0.1, 0 and then 0, so that is a minus 0.1. So the threshold function will give me a 0, so this is correct now. So further, now let's check for 0 1 with these modified weights if this is giving me the correct output or not. In that case, here it gives me a 1. After passing threshold function, it gives me the output as 1. For the second neuron, it gives me a 0.7, which is a 1, and after passing through the output layer, it gives me the output as 0.1, yeah, which is correct. So now the weights are also optimized. So this is how the multi-layer perceptron training works, and here I have taken these references, and that's all for now. Jazakallah khair.